If you look closely at the cover of your science textbook, you will find a single guiding word at the top: curiosity, or in Kannada, kutuhala. It is a signal that science is an active investigation. It involves looking at the intricate lines on a fallen leaf, watching a magnetized needle spin in a bowl of water, or measuring the speed of a car on the road. These things are connected. A plant, a magnet, and a moving car each follow specific patterns that we can uncover through careful observation. Mastering science means learning how to read these patterns for yourself, starting in your own backyard. Look at this diagram of a leaf. The arrangement of these water-transporting veins is called venation. It provides a map of how the plant functions. On the left, we have a hibiscus leaf. Its veins branch out into a scattered, net-like pattern. This is reticulate venation. On the right is a blade of grass. Here, the veins run in straight, non-intersecting lines from top to bottom. This is parallel venation. These leaf patterns correspond to the seeds the plant produces. A gram seed splits into two equal halves, known as a dicot. A maize seed remains a single solid piece, known as a monocot. There is a consistent link between these two features. Plants with reticulate leaves have dicot seeds. Plants with parallel leaves have monocot seeds. By observing the surface of the leaf, you can accurately predict the structure of the seed without ever digging up the plant. We can apply this same observational logic to physics by building a directional compass using a simple iron needle. In this setup, a magnetized needle passes horizontally through a rubber cork, which floats on the surface of a bowl of water. The cork provides buoyancy. It lifts the needle so it can spin freely, removing the friction that would occur if the needle were dragging against the bottom of the bowl. Once the water is still, the needle stops moving. It aligns itself with the Earth's natural north-south magnetic field. By eliminating physical friction, we allow the planetary magnetic field to guide the needle's direction. To accurately share what we observe about movement, we must use the precise language of scientific measurement. Scientific units follow specific formatting. They are written in lowercase, they are never pluralized with an S, and they do not end with a full stop. 10 kilometers is written as 10, space, and a lowercase km. Correct measurement allows us to define motion. To prove an object has moved, we identify a fixed reference point. We measure the changing distance of the car against the stationary tree to confirm its position is changing over time. Motion takes several forms. A car driving on a straight highway is in rectilinear motion. The hands of a clock moving in a round path are in circular motion. Then there is oscillatory motion. This is movement that goes repeatedly back and forth from a specific central point, like a child on a swing or a clock pendulum. Standard units and defined reference points give us a universal way to document these movements, whether we are tracking a pendulum or a car. We have navigated 3 different domains today, linking leaf patterns to seed types, using magnetism for navigation, and standardizing the rules of motion and measurement. Your next step is to look for these patterns in your own environment. Identify the venation of the plants near your home and record the distance to your school using the correct scientific notation. Applying these methods changes how you see your surroundings. A simple walk home becomes an exercise in identifying species, measuring motion, and testing the physical laws that govern the world.